everyone, here is for podcast 1.2, Understanding Points, Lines, and Planes. And so what we're going to be focusing on for today is the very next section, which is basically the building blocks of geometry. And so we're taking a look at what do we all need to make certain things work in geometry and what are individual pieces. So really big vocabulary day. So we have lots of vocabulary that we're going to talk about. And so a couple of them that are in our notes, and then there's actually a few that are not in our notes. And so we'll talk about those too. So first things first, so a flat surface determined by three non-collinear points, that would be what we call a plane. So a plane could be the floor of your house. It could be the ceiling of your house. It could be the high school parking lot. It's a plane, so it's considered a flat surface. And so that is what we would be dealing with if we were looking for that definition. So some of these you're going to have to jot down definitions, and that's okay. If points are on the same plane, then we call that something called coplanar. So coplanar is when we have same points on the same plane. You can have two lines on the same plane. So then it's going to be considered coplanar. So that would be that definition. Collinear is very similar. Collinear is points that are on the same line. Students have a tendency to accidentally mix these two up. And so what I always think about is collinear. Co again means share. Line, of course, means line. So they're sharing a line. Coplanar, they're sharing, but they're sharing a plane. And again, if you just kind of look at the word, that will help. A speck in space that's represented by a dot would be a point. And of course, if we have something that's being determined by 2 points and extends in both directions, that would represent a line. Now, there's a couple more definitions that are on here that are not necessarily on this lovely sheet right here. But it's in your notes. And so we have all the ones here except for ray and segment. And so for ray is similar to a line. It's actually a subset of a line. So a ray starts from a starting point. And it's going to go in one direction infinitely. It's something that you can't measure, just like a line. It's not measurable because, again, you have it going to infinity. The biggest thing with the ray, you want to make sure that our symbols are always pointing a certain direction, which is going to be to the right. A segment is also a subset of a line. It's basically connecting 2 points, and it can be measured. And that's why we work with segments a lot, because we can actually measure them and we can actually do stuff with them. And so that's why we would use segments more often. The next thing that we're going to be writing down is our 5 postulates. And so for our 5 postulates, these are postulates in something that we assume is going to happen by blind faith. Again, a postulate is something we just believe in. It doesn't necessarily have to be something that therefore is proven true. So that's a little bit different between a postulate and something called a theorem. So postulates are kind of the ground rules. And so some of the ground rules, and these are the big 4 for Euclidean geometry. Postulate 1.1, 2 points determine a unique line. Most people have heard that thing before. The closest distance between 2 points is a line. Postulate 1.2 is if I have one line and another line, and if they intersect, which we did back in algebra, then we would realize that they're going to intersect at 1 point. Postulate 1.3 is talking about that 3 non-collinear points is what is needed to determine a plane. So again, 3 non-collinear points. Non-collinear means not on the same line. And then postulate 1.4, if 2 planes intersect, then their intersection is a line. And that's a big one for students. Students really struggle with that because they see a cube and they think of where they intersect and they think it's a segment. However, it can be extended in opposite directions, so their intersection is always considered to be a line. When we look at symbols, again, some of our examples, a line would be something that has the arrows in the beginning and at the end. It is something that cannot be measured. In symbols, it would look like something like that. So our first two examples would be examples of lines. For segments, again, it's going to be where it has two endpoints. It will look like that in symbols with just a simple bar. And here's another example of a segment, GE. Array, this is a bad example. We never want our array symbol to go to the left. So this one's slightly evil, so we should probably just say goodbye to him because he's naughty. Our array symbols, we always want to be going to the right, even if the picture is going to the left. And so, again, that's what a picture of an array would look like. It's going infinitely in one direction. But if we were labeling it, we would actually label it DC with the symbol going to the right. So this is just a quick reminder of that we need to make sure that, again, wherever its start point is for the lovely ray is the letter that you start with. Okay, so then we start in getting into our examples. And so these are the 10 examples that we have next in our notes. So the next thing we're figuring out is which is best modeled by a point, line, or is it going to be a plane? You can't see the plane part though. So there it is, it's hiding. So a star in the sky. Think about what that would be. And so that will be a point. Because it's just a dot, we're looking at it, so from our point of view, it's just a point. An ice skating rink, well, that's something flat, and so therefore that would be an example of a plane. A telephone wire strung between poles. Well, if I have a choice of point, line, or plane, a wire is going to look more like a line than anything else, and so that's going to be my example. For the next part, 4, 5, 6, and 7, we're looking at the picture to the right. And so it's asking questions and using our vocabulary. So it's important to know our vocabulary for this part. So it's asking me if H, J, K, and L are coplanar. That means, are they all on the same plane? And yeah, all they are. They're on the top plane. So I would just say yes, they are coplanar. Next one. Name 3 lines that intersect at point X. Oh, well, I have an XW, and I'm going to put a little line symbol. I'm putting a comma because I need to have a second answer here. I could have KX with an arrow, or you could call it XK if you wanted to. And I also could do XY or YX. So there's 3 lines that intersect at X. Next, are points X, Y, or Y and W, are they collinear? Think about what collinear means. That means on the same line. So let me look. W, X, Y. No, they don't make a straight line segment, so they are not collinear. So that would be a no. Next one. What points do plane WXYZ and segment HW have in common? You could actually look at the letters. That would be one technique. Or you could actually just figure out where that plane is. So that plane of WXYZ is the bottom face. And then we have segment HW, which is this segment. So then we would have to see, well, where do they intersect? Well, they intersect right here at W. And since it's a point, we can just say a big capital letter of W. We're going to skip that one. A couple of extra slides here that we don't necessarily need. These are our last ones. So for these, we're going to be looking at and drawing a picture that's going to represent what we're going to be seeing in space. So we have lines JK and EF are not in plane M, but intersect at plane M at X. For 9, we have points R, S, and T are in plane M, but W, that point doesn't lie in plane M. And then finally, we have lines M and N intersect at point Q. They're actually in opposite order. 10 is actually the easiest one, so I'm going to start out with number 10. Lines M and N intersect at point Q. So I can just draw a line, and I'm going to put a little italics letter that can represent that line M. And then maybe I will put line N going this way. And so this can be N. And notice it gave me the name at intersection point, which is Q. So here's line M, here's line N, and then there is point Q. So there's my picture. Next one, R, S, and T are in plane M. Well, a plane is a flat surface, so usually what we do is make some kind of funky parallelogram. We're going to put kind of a funky looking M in the corner because that's going to represent its name. R, S, and T are somewhere on here. You probably don't want them to be linear because a part of being a plane means they're not going to be collinear. But somehow W is not going to be on that plane. So this one's a little bit hard to imagine because we're drawing on something two-dimensional and we really want something three-dimensional. So I could just imagine like a point above it, and that would be considered well enough. So like if you had like something flat, like a binder, and then imagine like taking a pencil in your hand and looking at the point of your pencil and having that be above your binder. That would be a consideration of what that picture would look like. Last one, these two lines are not in plane M, but intersect plane M. Okay, so here's plane M. Well, if they're not going to be on it, but they intersect, so that kind of tells me is that they're going through it. So I kind of need to kind of draw a little arrow to show that it's kind of going through. And so this is J, down here is K, and then maybe this part, here's the other line. And so there's E, cutting through, and F. And then again, this is the intersection point, which is X. And that kind of basically recaps section 1.2 about the building blocks of points, lines, and planes in geometry. And as always, have a great day, Bulldogs.